Namaste. This is JB and Dr. Vishal Saxena, Associate Professor in Mathematics in Jayoti Vidyapeeth, Women's University, Jaipur. Today I am going to discuss about the module measure of central tendency, and the part which we are going to discuss about the topic that is arithmetic mean. So first we see the definition of measure of central tendency. Measure of central tendency are the numbers that indicate the center of a set of ordered numerical data, and the three most common measure of central tendency are the mean, median, and the mode. So these mean, median, and mode are the parts or the important parts of the measure of central tendency. Now we take the first topic, the topic arithmetic mean. It is a simple average of all items in a series. It is the simplest measure of central tendencies. So now we take the formula for arithmetic mean. This formula is given by x1 plus x2 plus x3 plus till xn upon n, and which is also called summation x upon n. Here we have taken n as the total number of data, and x1, x2, x3, xn are the data we have. So now we understand this with an example. Number of matches is equal to 5 plus 6 plus 7 plus 8 plus 9 is equal to 35, and the number of boys is equal to 5. So if we have to find the mean, then the mean can be given by the same formula, that is summation x upon n, and which is equal to 35 upon 5, and 35 is the value of the total number of matches, and 5 is the value of number of boys. So this is equal to 35 upon 5, which is equal to 7. Next, we discuss about the types of arithmetic mean. Arithmetic mean is of two types. The first type is simple arithmetic mean, and the second is weighted arithmetic mean. Now next, we discuss about the methods of calculating simple arithmetic mean. So we have different series like individual series and the discrete series, and third is continuous series, for which we can find the simple arithmetic mean by the different procedures. So one by one we take the calculation of arithmetic mean for three different series. First, we take the calculation of simple arithmetic mean for individual series. In case of individual series, the arithmetic mean may be calculated by two methods. One is called the direct method, and second is called the shortcut method. In the direct method, the mean is given by summation x upon n, and this equal to total value of the number of items divided by number of items. So here again, n shows the total number of data, and x shows the value of data. So summation x will be the total or addition of the data. Now we take one example to understand this. In this example, we are given that pocket allowance of 10 students in rupees. So the pocket allowance are given that 15, 20, 30, 22, 25, 18, 40, 50, 55, and 65. So we are given that the pocket allowance of 10 students in rupees, and the question is find out the average pocket allowance. So this is a question from the individual series, because in this question we are not given that the frequencies, just we are given that the data, and the data are all we have 10 data we are given that. So for this series, the mean is given by summation x upon n, and this is equal to 15 plus 20 plus 30 plus 22 plus 25 plus 18 plus 40 plus 50 plus 55 plus 65. So that means we have to add all the data which we are given that, and in denominator we have to take the total number of data, which is equal to 10 in this question. So the summation will become 340. So this is 340 upon 10, and this 340 upon 10 is equal to 34. So in this way, for this question, the pocket allowance of 10 students are given that, and the average pocket allowance of 10 students becomes that is rupees 34. So rupees 34 is the average or the mean value of the pocket allowance of the 10 students. Next, we can find out the mean by another method, and this method is known as shortcut method. This method is used when the size of the items is very large. In this case, the method is appropriate to apply. Uh, the calculations will become easy, and in this case, in the shortcut method, the mean is given by the formula A plus summation D upon N, where A represents the assumed mean, and assumed mean can be taken as any value uh, from the data we have. N represents the total number of items. So N represents the total number of items in this formula, in this method, and X represents the number of X represents the value of data, while D is called the deviation. Deviation is taken by A from the data, so that D becomes X minus A. So D is equal to X minus A. So to apply this formula, first we have to calculate the deviations, which is given by the formula X minus A, and we have to initially we have to assume one value from the data as assumed mean. And now then we have to apply the formula to find out the mean. So now next, calculation of arithmetic mean in discrete series or the frequency array. So all we know that what kind of discrete series is there. So discrete series is that series in which along with the data we are also given that the frequencies. So a series with frequencies and data is known as the discrete series. And for discrete series, how can we find arithmetic mean? We discuss about that. So for the discrete series, the arithmetic mean can be given by three different procedures: direct method, shortcut method, and the step deviation method. So these are the three different methods by which we calculate the arithmetic mean in for the three different series, for three different methods: direct method, shortcut method, and step deviation method. In the case of direct method, the formula by which we calculate the arithmetic mean is given by summation fx upon summation f, and where this f represents the frequencies of data, and x shows the data value or the value of data. So by this formula, we can calculate the arithmetic mean. And now we understand with an example this. So in this question, we are given that the weekly wages of weekly wage earnings of 19 workers. We are given that a table where wages in rupees are given that, and this shows the values of X. So the values of X are 10, 20, 30, 40, and 50. So these are the values of X, and the number of workers F is equal to 4, 5, 3, 2, and 5. So these are the values of number of workers. That means these are the values of frequency F. So to solve this question by the direct method, we have to make a table, and where the values of X should be shown, and the number of workers F will also be included, and along with, as required in the formula, the term summation fx is needed. So we take a column of fx, we take a row of fx where f is multiplied with the values of x. So that is 40. 10 into 4 is 40. Next is 20 into 5 becomes 100. And the next value becomes 30 into 3 becomes 90. The next value is there 40 into 2, that is 80. And the last value of fx will be 50 into 5, that is 250. So these are the values of fx, and the mean is given by summation fx upon summation f. So mean is given by summation fx upon summation f, and the summation f is equal to the sum of the all the frequencies, which means that 4 plus 5 plus 3 plus 2 plus 5, and it becomes 19. So as we are given that already in the question, there are 19 workers in the present question. So 19 is the value of summation f, while the value of summation fx is equal to like 40 plus 100 plus 90 plus uh, plus 80 plus 250, and this becomes 560. So summation fx is equal to 560, and which is equal to 29.47. So in this way, the mean wage earnings of 19 workers can be given by summation fx upon summation f, and that becomes 29.47, and we can write the answer as rupees 29.47 as the mean or the average wage earnings of the 19 workers. So this is the example we have solved, and we have taken this example by the direct method solution procedure. One more example we take, and in this example we are given that the marks obtained by 6 students in a class test are 20, 22, 24, 26, 28, and 30. So there are 6 students in the class, and we are given that the marks obtained by the 6 students. So the question is that one, that is find the mean or the mean marks. So because already we know that this kind of series is called the individual series, because just we are given that the data, and we are not given that the frequencies. So in this question where we are given that only data, so for the individual series, just we have to find the mean by the formula summation x upon n, and we know that how many students are there? There are 6 students. So the value of n is equal to 6, while the sum of the data is given by 20 plus 22 plus 24 plus 26 plus 28 plus 30. and which is equal to, and that is equal to 25. uh, that is equal to 306. So in this way, the value of the average, the value of the mean is given by the sum of the values and divided by total number of students, that is 6. So finally, when we take the addition of these, so we get the mean value as 25. So mean, that means 20 plus 22 plus 24 plus 26 plus 28 plus 30 divided by 6. It is 30 by 6, and by 6 just we have taken because there are 6 students, and this mean value becomes 25. Now next we are going to take one more example to understand this. In this question we are already given that the mean value and one missing value is there in this example, so we have to calculate the missing value. If the arithmetic mean of 14 observations, so 14, we have total 14 observations, and the observations are given that 26, 12, 14, 15, and the next value is x. X is unknown value. Then 17, 9, 11, 18, 16, 28, 20, 22, 8 is 17. So we are given that the mean value as 17 and the total number of observations as 14, and we have the different data. 14 observations are given that in this question. One value of one data is given that as x, so it means x is unknown value, and the question is here to find the missing observation. So now we start to solve the question. Given 14 observations are 26, 12, 14, 15, and then x, 17, 9, 11, 18, 16, and 28, 20, 22, and 8. So these are the 14 observations, and we are also given that the arithmetic mean value. So this mean value is given 17, and if we have to calculate, we have to find the value x. So we have to apply the formula of the arithmetic mean, and this is equal to mean is given by sum of observations divided by total number of data. So just we have to write in left hand side as 17 because the 17 is the value of arithmetic mean, and in the right hand side we have to write in numerator as we have to write the summation value of data in numerator. So that becomes 216 plus x divided by 14. So denominator is 14, and 14 shows the total number of observations, while 216 plus x, which is written in numerator, and it shows that the sum value of the all observations. And when we solve this equation, then we have to do in this way, like 17 into 14 is equal to 216 plus x, and when we solve this equation we will find x is equal to 22. So in this way the missing observation x can be given by 22, and just this is the question from the individual series, because we are not given that here frequencies, and we have applied simply the formula of arithmetic mean to find the missing value x. The second procedure, as all we know that here, is known as shortcut method. And in the shortcut method of estimated mean of the discrete frequency series, use the following formula. The formula is given by m is equal to a plus summation f into d upon summation f, where f denotes the frequency and a denotes the arithmetic mean term, uh, arithmetic mean which is assumed. So a shows the assumed mean, while m shows the arithmetic mean and a is the assumed mean. F represents the frequencies of data. D is called the deviation taken from the assumed mean, and summation F represents the sum value of all the frequencies. The formula by which we can calculate the derivation D is equal to x minus a. D is given by x minus a, and third is step derivation method. In step derivation method, we can use the formula to find arithmetic mean is m is equal to a plus summation f into d dash upon summation f multiplied by c. So m is equal to a plus summation f into d dash upon summation f into c. So this is the formula used. This is the formula used for the step derivation method. And now next we take the calculation of simple arithmetic mean in case of continuous series. In continuous series, again we have the three different methods. The first method known as direct method, second one is called the shortcut method, and third method is step deviation method. In the direct method, we can use the formula for arithmetic mean, that is summation fx upon summation f, and in the shortcut method, we can use the formula to find arithmetic mean as a plus summation f into d upon summation f. And third method is known as step derivation method, in which we can use the formula to find arithmetic mean is m is equal to a plus summation f into d dash upon summation f into c, where d dash represents d dash is the value x minus a upon c. So that is the value x minus a upon c, and these three methods are for the continuous series, and continuous series is also known as the grouped data. Next is we take example for this. So the now mean value of the data can be obtained by using direct method, and in this example we are given that a series, the series known as the continuous series for the marks obtained by students and the number of students. The question is marks in statistics of students of class 11th are given below. Find out the arithmetic mean. So first we are given that the marks in class interval form, like as 0 to 10, 10 to 20, 20 to 30, 30 to 40, and 40 to 50. And number of students 5, 12, 14, 10, 8. And the mid values 5, 15, 25, 35, and 45. So fx, we have to calculate the value of fx, and it will be like 25, 180, 350, and 350 and 360. So initially we have calculated the term mid value, and mid value can be given by the lower limit plus upper limit upon 2. So 0 plus 10 upon 2, that is like 25. 10 plus 20 upon 2 is 15. 20 plus 30 upon 2 is 25. 30 plus 40 upon 2 is 35. 40 plus 50 upon 2 is 45. So these are the mid values. And the number of strands, that means we are given that frequencies. So we had multiplied f with the values of x. So the column of fx is 25, 180, 35, 350, 350 and 360. That is m is equal to summation fx upon summation f, and it will be equal to 25.82. So the arithmetic mean is given by 25.82 marks. Now we take one more example to find the mean. So x, the table of x and f are given that. So we have this table for the values of x and f, and this table shows that data are for the ungrouped data or the discrete series. So if we have to find the arithmetic mean in this question, then we have to use the formula mean is equal to a plus summation f d upon summation f, a plus summation f d upon summation f, and where a means the assumed mean, f represents the frequency, and d represents the deviation from the assumed mean. So first we write the values of x, and then we write the values of f. So values of x are given by these values like 900, 950, 1000, 1100, 1260, and 1440, 1500. In the similar way, we are given that the frequencies and d, which is equal to x minus a. X minus a, and a is taken as assumed mean is taken as 1000. So we will calculate the values of d, x minus a, like minus 100, minus 150, 0, 100, 260, 440, and 500. And the values of fd are minus 2600 and minus 1100, 0, 1900, then 3900, 1320, and 1000. So we have to find the summation f, which is equal to 105, and the value of summation fd, which is equal to 4420. So then we have to use the formula to find the arithmetic mean as a plus summation fd upon summation f, which is equal to 1000 plus 4420 upon 105, and that is equal to 1042.1. So the mean is 1042.1. Now next we take the step deviation method, and we are given that a series in continuous form. Find the mean for the following data. So in this question, first we have to write the class interval, then we write the frequency values. Next we calculate the values of x, means mid value as the lower limit plus upper limit upon 2 from the class interval. D is equal to x minus a, and a is taken as 275, which is the assumed value. So we have taken assumed value as 275 from the column of x, and then we have to calculate d equal to x minus a, then u is equal to d upon h, and f into u is just we have to calculate. So f into u we have to multiply the column of frequency with the column of U. After solving these values, after writing these values, we have to find the summation f, that is equal to 200, and the summation f into U, which is minus 35. Therefore, the mean is given by A plus summation f into U upon summation f into h. So this is the formula for the step deviation method. So A is 275 and summation FU is minus 35. Then F summation F is 200 and H is 50. So just when we solve these values, when we solve this equation, the term, then we will get 266.25 and this is the required arithmetic mean for the question. Now next is the weighted arithmetic mean. The weighted arithmetic mean is given by x bar is equal to w into x upon w, or summation wx upon w, summation w, where each number x is assigned a corresponding positive weight w. So the weighted arithmetic mean x bar is given by summation wx upon summation w. X represents the data and w represents the positive weight corresponding to that data. Combined arithmetic mean is given by the formula, like suppose we have two where when there are when there are more than two parts of the series, the following formula is used to work out combined arithmetic mean. So m1 comma 2 is equal to m1 n1 plus m2 n2 upon n1 plus n2. So this is the arithmetic this is the combined arithmetic mean, and m1 is the mean from the for the first series, and m2 is the mean for the second series, and n1 and n2 are the size of those two series. So in this way we have this formula for the combined arithmetic mean, and if we have the more than two series, suppose we have n series, then this mean is given by m1 n1 plus m2 n2 plus till mn nn upon n1 plus n2 plus n3 plus nn. Like for example, suppose we are given that a table where just we weight w are given that with observations x, then we multiply w and x because we need to find the summation wx and summation w. So we take a column of wx and this becomes 2, 28, 40 to 24 and 294 as the value of wx, summation wx, while the summation w is equal to 56, and therefore the mean is given by summation wx upon summation w. So 294 upon 56 and which is equal to 5.25. So with this I conclude today's lecture. Thank you.